Hi viewers, welcome to all. Here we are discussing about a project Hamming based single fault error corrections code. Here the digital filters are widely used in signal processing and communication systems. In some cases the reliability of those systems is critical and the fault tolerant filter implementations are needed. Over the years many techniques that explore the filters or properties to achieve fault tolerance have been proposed. As a technology scale, it's enable more complex systems that incorporate many filters. In those complex systems, it's a common that some of the filters operate in parallel. For example, by applying a same filter to different input signal. Recently, a simple techniques that explores the presence of parallel filter to achieve a fault tolerance have been presented. In this brief, that the idea is generalized to show that the parallel filters can be protected using a error corrections code, in which each filters is equivalent of a bit of a traditional ECC. The new schemes allows more efficient protections when the number of filter is large. The technique is evaluated using a case study of parallel filter finite impulse response, showing the effectiveness in terms of protections and implementations cost. Now we can verify the project. So here you can verify the proposed abstract. This code is mainly focused for the Hamming based single fault error corrections. So this is a proposed architectures. What we have to do in this project means we are given a input to this architectures. That input is x1, x2, x3, x4. That is a 4 input. So this 4 input directly given to the original models and also given to the coding model, encoder model. So this coding model, it will encrypt the code, and it will be given into this redundant model. So this original models and redundant model will have designed with the Hamming code. That code will encode the data and it will be given to y1, y2, y3, y4 and z1, z2, z3. So then it will be given into the single fault error corrections. So here the y1, y2, y3, y4 it's having a original data, and z1, z2, z3 it's a redundant data. So here the single fault error corrections, we need to solve this y1, y2, y3, y4 as same as the encoding technique x5, x6, x7. So then we will get a temporary signal. That signal we need to compare with this SZ signal. So we will find the error. If the error happen, we need to correct the error using single fault correction. So then the corrected data will applicable in the YC1, YC2, YC3, YC4. So for this technique we have used this reference paper, fault tolerance parallel filter based on error corrections code. So here we have used so this is the architectures and this is a S-bit correction. Table 1 will showing error locations in the Hamming code based error bit correction. So based upon this S-bit sequence 0, 0, 0 no error, and 1, 1, 1 D1 will be error, and 1, 1, 0 D2 error. So as per that we need to correct the error. So in the particular area. So we have developed this code in Verilog HDL. And we have simulated this code in modelism software. So here you can check the input data and you can check the output data. So wherever you need we can check the data. So if we need a manual error, we need to force the value to 1 and we can check the manual error. It will be corrected or not. So here you can check. So we are forcing the manual error up to 1, 2, 3, 4, 5, 6, 7, 8, 9 clock cycle. So in the 9 clock cycle it will correct the error in y value. So in the time period, so it will produce the error signal, error 0, 1, 2. So as per that we can verify the error corrections happen or not. And the same thing we have synthesized in Xilinx Spartan 6 LX9 FPGA, and here you can verify the number of slice registers, number of LUTs, number of occupied slices, number of IO bits. And you can check the delay report in synthesize. So here you can check the delay. It will take 11.341 nanosecond, and you can check the RTL schematic. So this is the top model of the RTL schematic. And here you can verify the internal architecture. Okay, so code encryption, Hamming code, okay, and the single fault error corrections. So inside of the Hamming code, it's having an architecture, okay, and this is a single fault error corrections code. Okay, so then we can check the power report. Okay, tools X-Power analyzer. Okay, so here we can verify the documentations part. Okay, so proposed abstract, fault tolerance error corrections notes, Hamming code, single fault error correction notes, advantages, disadvantages, and VLSI related notes. Literature survey and references. Okay, thank you.
If you need more video related to VLSI project, please like and subscribe this channel.